Welcome back, everyone. In this tutorial, we're going to explore one of the most powerful open-source AI projects available today, Llama.cpp. If you've ever wanted to run large language models completely offline without paying for cloud services or sending your data to external servers, you're in the right place. By the end of this video, you'll know how to download AI models, run them locally on your Windows computer, switch between different models, start interactive conversations, launch a local AI server, and use many of the advanced features that make Llama.cpp such a powerful inference engine. Everything we'll do runs directly on your own machine. No internet connection is required after downloading the models. Your conversations stay private, your prompts stay local, and you're in complete control of your AI environment. Throughout this tutorial, I'll explain every command step by step, so even if you've never used Llama.cpp before, you'll be able to follow along without any difficulty. Let's get started. Before running any commands, make sure you've already downloaded and built Llama. Now that Llama.cpp is ready, the next step is downloading an AI model. Unlike cloud-based AI services, Llama.cpp doesn't include a model by default. Instead, you choose the model that best fits your hardware and your use case. Today, most local AI models are distributed using the GGUF format. GGUF is specifically designed for efficient local inference and is the standard format supported by Llama.cpp. To download a model, visit Hugging Face, which hosts thousands of open-source AI models contributed by researchers and organizations from around the world. You can search for models such as DeepSeek, Qwen, Gemma, or Meta's Llama models. When browsing the available files, you'll often see several quantized versions of the same model. If you're planning to run inference on a CPU, one of the best choices is the Q4KM quantization. It provides an excellent balance between model quality, memory usage, and inference speed. After downloading the GGUF file, simply copy it into the models folder inside your Llama.cpp directory. Your folder might eventually contain several models, allowing you to switch between them whenever you want without reinstalling anything. In my setup, the project is located on the E drive, inside a folder named Llama.cpp. Inside this folder, you'll find the executable files, a folder that stores all of your AI models. To make things easier, open Command Prompt and navigate to this folder using the following command. CDDE Llama.cpp. The delete option changes both the drive and the directory, ensuring that every command we run during this tutorial works correctly. From this point forward, every command assumes that we're already inside this folder. Now comes the exciting part. Let's run our first local AI model. Execute the following command, llama.cpp models. Let's break down this command. First, we launch llama.cpp, which is the command line application responsible for loading and running the model. The M option specifies the model file that should be loaded into memory. In this example, we're using a Llama.32 GGUF model. Next comes the AP option. This stands for prompt. The text inside the quotation marks is the instruction that we'll send to the AI. In this example, we're asking the model to explain anything. Finally, we use the T option to specify the number of CPU threads used during inference. Here, we're using 4 threads. Once the model finishes loading, it immediately begins generating its response directly inside the terminal. Everything happens locally. No information is sent to external servers. One of the biggest advantages of Llama.cpp is how easy it is to switch between different AI models. You don't need to reinstall the software. You don't need to modify any configuration files. Simply change the model specified after the M option. For example, instead of loading a Llama model, we can load a DeepSeek model. Everything else remains exactly the same. This makes it incredibly easy to compare different models and discover which one performs best for your particular tasks. Some models are optimized for coding. Others are better at reasoning. Some focus on creative writing, while others are designed for multilingual conversations. Switching between them takes only a few seconds. Depending on the version of Llama.cpp you're using, additional command line options may be available to customize how prompts and generated text are displayed. Since these options occasionally change between releases, it's always a good idea to check the built-in help whenever you upgrade Llama.cpp. Reviewing the available options ensures you're using the most current command syntax. You can type questions, receive responses, and continue conversations just as you would with an online AI assistant. The difference is that everything happens entirely on your own computer. No prompts leave your machine. No responses are generated in the cloud. Everything remains local. If you've never worked with local servers before, you might wonder what localhost actually means. Localhost is simply a special network address that always points back to your own computer. When you visit localhost, you're not connecting to the internet. You're connecting to a program running on your own machine. This is one of the reasons Llama.cpp is so popular. It provides the convenience of a web-based AI assistant while keeping all computation private and under your control. One of the most powerful features of Llama Server is its OpenAI-compatible API. This means that many applications originally designed to work with OpenAI's online services can also communicate with your local Llama.cpp server, often with little or no code changes. Privacy is one of the biggest reasons many people choose Llama.cpp. When using cloud-based AI services, your prompts are transmitted over the internet to remote servers where the model performs the computation. With Llama.cpp, the model runs entirely on your own computer. Your prompts remain local. Your documents remain local. Your source code remains local. Even if you disconnect your computer from the internet after downloading the model, Llama.cpp continues to work normally. This makes it an excellent solution for developers, researchers, businesses, and anyone working with confidential information. So far, we've been interacting with our AI models directly from the command line. While this approach is perfect for learning and testing, many real-world applications require something more flexible. Instead of opening a terminal every time you want to ask a question, you can transform Llama.cpp into a local AI server. Once the server is running, you can chat through your web browser, connect desktop applications, build your own AI software, or integrate the model into your existing development projects. Let's see how it works. The easiest way to make your model available to other applications is by launching Llama Server. Run the following command, llamaserver.xem models. Let's examine the command. The M option specifies which model to load. The .z option defines the context window, and T tells all Llama.cpu threads to use during inference. When the server starts successfully, it loads the selected model into memory and begins listening for incoming requests. Unlike Llama.CLI, which processes one command and exits, Llama Server continues running until you stop it. It acts as a local AI service that other programs can communicate with. Once the server is running, open your favorite web browser. Navigate to the following address. If everything is configured correctly, you'll see the built-in chat interface provided by Llama.cpp. This interface allows you to communicate with your local AI model directly from the browser without installing any additional software. Another advantage of Llama.cpp is its flexibility. It isn't limited to a single AI model. As long as the model has been converted to the GGUF format and is supported by your version of Llama.cpp, you can easily switch between different families. For example, you might use Llama for general-purpose conversations, Qwen for coding and multilingual tasks, Gemma for lightweight inference, DeepSeek for reasoning, or many other compatible GGUF models released by the open-source community. Changing models usually requires nothing more than specifying a different file after the M option. This flexibility allows you to experiment and choose the model that best fits your workload. The open-source community also provides models that have fewer conversational restrictions than many mainstream AI assistants. Examples include various Dolphin, Hermes, and other community fine-tuned models. From Llama.cpp's perspective, these models are loaded exactly like any other GGUF model. At this point, you've transformed Llama.cpp from a simple command line application into a complete local AI platform. You learned how to launch a local AI server, access it through a web browser, use the OpenAI-compatible API, configure server mode, understand automatic CPU optimization, protect your privacy by running. These capabilities are what make Llama.cpp much more than a simple inference engine. It can serve as the foundation for local AI assistants, development tools, research environments, and custom applications. Now it's time to use it for real work. This is where Llama.cpp becomes much more than a chatbot. We'll review Python code, detect C++ race conditions, analyze projects, explain error logs, generate unit tests, refactor legacy code, and even work with vision models that can understand images. Let's start with a practical Python example. Suppose we have a small Python script called badpython.py. It works, but the variable names are unclear, there are no type hints, and the overall style is difficult to maintain. This is incredibly useful for code reviews, teaching, and quickly understanding unfamiliar scripts. We can go even further and ask the model to rewrite the program using modern Python best practices. We can ask the model to explain a program line by line. This turns Llama.cpp into a local programming tutor that works entirely offline. Students can ask questions, experiment with code, and learn without relying on cloud services. Now let's switch to C++. Imagine a program where two threads increment the same global counter without synchronization. Sometimes the final value is correct. Sometimes it isn't. That's a classic race condition. We can ask Llama.cpp to analyze the source file. The model can identify the unsynchronized access to the shared counter and explain why the result becomes unpredictable. This is a powerful demo because it shows Llama.cpp helping with real software engineering tasks. After finding the problem, we can ask the model to fix it. The generated solution typically introduces STD, atomic or STD, mutex, and explains why synchronization is required. If multiple source files are combined into a single text file, Llama.cpp can review the project as a whole. This is useful for audits, code reviews, and understanding legacy projects. Keep in mind that larger projects may require larger context windows and sufficient RAM. Another practical workflow is analyzing logs. Suppose an application crashes and produces a stack trace. Instead of searching the internet for every error message, we can ask the model to explain it. The model can summarize the important lines, identify likely causes, and suggest troubleshooting steps. This is especially useful for beginners who find raw stack traces difficult to read. We can also ask the model to create tests automatically. This can save time when building test suites and provides a useful starting point for further refinement. So far, we've worked only with text. However, Llama.cpp can also run vision-capable models, such as LLaBa. These models can analyze images when provided with both the main model and the multimodal projection file. For example, the model can describe objects, scenes, text, and other visible content inside the image. Vision models can also extract visible text from images. This can be useful for receipts, screenshots, scanned documents, and photos containing text. Another practical example is troubleshooting. The model can read the screenshot and provide a human-friendly explanation of the error message. This is a very impressive demo for YouTube because viewers immediately understand the benefit. Llama.cpp also supports embedding models used for semantic search and retrieval systems. With an embedding model loaded, you can generate vector representations of text. These embeddings are commonly used in search engines, recommendation systems, and retrieval augmented generation pipelines. While this topic is more advanced, it's worth mentioning because it shows that Llama.cpp is useful for much more than chatting. Now, you've seen Llama.cpp perform real development tasks, reviewing Python code, explaining programs, detecting C++ race conditions, analyzing projects, interpreting error logs, generating unit tests, refactoring legacy code, describing images, extracting text from screenshots, and creating embeddings for semantic search. These examples demonstrate that Llama.cpp is not just a local chatbot. It can become a practical assistant for software development, education, research, and automation.